My name is Namiko Saito, and I am presenting a work on tool use model considering tool selection on the robot using deep learning. Daily space is a complex environment, and robots are required to perform various tasks. If robots could use tools like people do, their ability to execute tasks will improve. So, in this research, we propose a tool use model for robots that does not require labels and considers end-to-end sequential task execution, from tool selection to operation. As for tool selection, there are two types need to be considered. First is the selector tool according to its shape, whose function meets the purpose. And the second type is the selector tool of the appropriate size basing on the distance to the target. Therefore, we constructed the model that can consider both selection. This is the proposed model. The model comprises two modules. The first one is a feature extraction module, which can compress the number of dimensions, for which we use convolution autoencoder, CAE. And second is a motion generation module, which can learn and generate the time series of data, for which we use multiple time scale neural network, MTRNN. At first, we guide the robot to experience some tasks and record image data and motor angle data. As the dimension of image data is considerably larger than motor data, we compress it by feature extraction module and take low-dimensional image feature. Then we put it to motion generation module. We also input motor angle data taken while experienced by the robot. At this time, we put task command which tells an order by human, an initial image feature which can prevent lack of information about the environment, even if the tool or object cannot be seen because it is occluded by the robot arm. All the data are learned by motion generation module, and it outputs the next time step data. Then the robot can move according to the output motor angle data, and repeat this again and again. This is the experiment setup. We prepared two stick-shaped tools and two rake-shaped tools, and allowed the robot to do pulling actions or sliding actions. The initial positions of tools are as shown in figure on the right, and we evaluate using tools put on the red point. We will show the result of the online generation with tools set in the untrained positions. We ordered the robot to slide the object and set the object at near position. We also show the images predicted by the robot in online. Of the two tools set in front of the robot, which has a function that can slide is a stick, the robot could select it as expected, then approach the object, and succeeded in sliding. And the second example, we ordered the robot to pull the object and set the object at third position. We also show the images predicted by the robot in online. Of the two tools set in front of the robot, which can approach to the object is the long tool. The robot could select it as expected, then approached to the object and succeeded in pulling. We constructed a model that can consider tool selection and execute the whole task without labels, and the robot could generate motion with the model. Thank you for watching.